Hello everyone, my name is Sugarmaran and my metric number is 206426.
Hello everyone, my name is Nurul Syafiqah binti Ismail and my matrix number is 206201.
My name is Haziq Rajak and my matrix number is 20081.
My name is Akmal bin Hambali and my matrix number 206716. Guys, wake up, we are too late.
What time is it?
Oh, 9 a.m.
Oh no.
Good morning, everyone. Why are you late for the class today?
Sorry sir, we fell asleep.
It's okay, guys. Next time, don't be late. Today, I will introduce to you a new topic called Biot-Savart'S law. So, moving on. Introduction to the two great scientists. The Biot is born at April 21 in the year 1774 in Paris. Biot is a French physicist, astronomer, and mathematician who discovered the Biot-Savart law of magnetostatics with Felix Savart, established the reality of materials, made an early baboon flat, and Biot studied the polarization of the light. So moving on, the second scientist is Savart, born at 30 June in Mézières, French. So Savart is also a physicist and a mathematician who is primarily known for the Biot-Savart law of electromagnetism, which he discovered together with his colleague Biot. So moving on. So the Biot-Savart law is called by the Earnsted experiment. This experiment shows that the force of a long straight current carrying wire on the magnetic poles is a lateral force. So in order to reveal the universal quantitative law of the force of current on the magnetic poles, the Biot and Savart believed that the force of the current elements on the magnetic pole should also be perpendicular to the plane formed by the current elements and the magnetic poles, that is also a lateral force. Through experiments on the force of long straight and bent current carrying wires on the magnetic poles, they obtained the relationship between the force and the distance, also the bending angle. So that's all for today. We are running out of time, so before we end our class, I would like to give you a task regarding Biot-Savart law topic. You guys need to find about 4 aspects of Biot-Savart law, which are definition, equation, application, and also the problem solving. So we shall end our class right now. Thank you, everyone. Have a nice day.
Thank you, doctor. Guys, I have found the definition of Biot-Savart law. Okay, let me explain here. Electric fields and magnetic fields might seem different, but they are actually part of one larger force called the electromagnetic field. Charges that aren't moving produce electric fields, but when those charges do move, they also create magnetic fields. For example, a magnet is only a magnet because of moving charges inside it, and charges moving in an electric wire also produce magnetic fields. If you move a compass near to an electric wire, you will find that the compass needle changes direction. The Biot-Savart's law is an equation that describes the magnetic field created by a current carrying wire and allows you to calculate its strength at various points. The direction of the magnetic field is always in a plane perpendicular to the line of element and position vector. It is given by the right-hand thumb rule, where the thumb points to the direction of conventional current and the other fingers show the magnetic field's direction. The magnetic field is created by the constant current consists of circular loops directed along your curled fingers.
Oh, now I understand what is Biot-Savart'S law about. Guys, I have found something new.
Hey!
Yeah, what's the matter?
I have found something new about the equation of Biot-Savart's law.
Okay, this is the equation of Biot-Savart's law, which is dB bar equal mu naught divided by 4 pi times I dl sin theta over r square. And we know that mu naught is magnetic constant, which is the permeability of free space, and I refers to the current, and r is distance between element and point, and dl is the length of element, and the last one is theta, which is the angle between dl bar and r bar. For example, if AB represents a current element of a conductor and PQ carrying current I, and R bar the position vector of P from the current element AB, there is length of dl bar. Then the law states that magnetic field dB at P due to current element depends on dB is directly proportional to I, and dB is directly proportional to dl. Next, dB is directly proportional to sin theta, which is the angle between dl bar and r bar, and dB is directly proportional to 1 over r square. Next, when we combine it, we get dB is directly proportional to I dl sin theta over r square, and we get dB is equal to mu naught over 4 pi times I dl sin theta over r square. And we know that mu naught is equal to 4 pi times 10 power of -7 pm over A, which is the permeability of free space. And lastly, in the vector form, dB bar is equal to mu naught I dl cross r bar divided by 4 pi r cube. And furthermore, everyone must know that the direction of dB is given by right hand rule. And lastly, the unit of the equation of Biot-Savart's law is equal to 1 Tesla or 1 T. And that's all from me. Thank you.
Guys, do you guys know what is the application of Biot-Savart's law?
No.
So, one of the application of Biot-Savart's law will be based on cell towers. Cell tower is used to ensure proper elevation to antennas that receive and transmit radio frequency from cell phones and other electronic devices. Cell towers emit electromagnetic radiation to the surrounding. And here comes the real application of Biot-Savart's law in solving or determining the intensity of magnetic field at a particular place from the cell towers. Therefore, we can use Biot-Savart's law to calculate the safe distance at which we can place these transmitters or cell towers so that it does not affect the people near those towers.
So Shuri, what the ideas application of Biot-Savart's law?
I think I found an interesting video with the application of Biot-Savart's law. Let me watch together. Hello everyone, today we are going to learn the application of Biot-Savart's law. Biot-Savart's law is also used in the calculation of magnetic responses even at the atomic or molecular level, such as in chemical shieldings. Chemical shieldings, referred to as atomic shielding or electron shielding, describes the attraction between an electron and the nucleus of an atom. The spinning of the electron around the nucleus of an atom creates a tiny magnetic field which slightly changes the difference between the energy levels. Therefore, Biot-Savart'S expression is used to determine the magnetic shield density containing special contribution to the nuclear magnetic shield of a nucleus. Chemical shielding in nuclear magnetic resonance is extremely important to scientists as it gives vital information about the local structure surrounding the nucleus of an element. In addition, chemical shift is used to determine the structure of an element, especially in organic systems.
Oh, very nice, Shuriien. Besides that, is there any other application of Biot-Savart's law?
I guess I have one. Let me show you something. Wireless power transmission is the transmission of electric energy without wire as a physical link. In a wireless power transmission system, a transmitter device driven by electric power from a power supply source generates a time-varying electromagnetic field which transmits power across space to a receiver device, which extracts power from the field and supplies it to an electrical load. See that the shorter the distance between the transmitter and the receiver coil, the higher the intensity of magnetic field and the brighter the LED lights up. Therefore, based on the law of Biot-Savart, the magnetic induction between the coil can be obtained. So, here are some examples of wireless power transfer in our daily life, such as RFID tags and wireless charger. Haziq, so
Yes.
far we have learned about the definition, application and the equation of Biot-Savart's law. What else we need to search for?
What about problem solving?
Let me explain about the problem solving. Hello everyone, I am Syafiqah and now I will explain about the solving problem using Biot-Savart's law. So without further ado, let's begin. So here is the first problem. A wire placed along the north-south direction carries a current of 8 ampere from south to north. Find the magnetic field due to a 1 cm piece of wire at a point 200 cm northeast from the piece. Because the point is located at the northeast from the piece, so we can indicate that the angle is equals to 45 degrees. So here is the solution. Firstly, we need to extract the information from the question, which is the value of I, VL, R, and also theta. After that, we need to substitute all the given information into the Biot-Savart's law equation, which is here. After substituting all the value into the Biot-Savart's law equation, we get to solve it and then we obtain the value which is 1.414 times 10 to the power of negative 9 Tesla as the magnetic field of the wire. Next is the direction. We need to find it by using the formula of right hand thumb rule. So the thumb is using to represent you the current direction, while the remaining fingers shows you the direction of dB. So in this case, the direction of the current is upward. So for that, dB is into the plane of the paper. Next, moving on to the second problem. In this second problem, you can see that we need to find the magnitude and direction of the magnetic field at the center of the circular arc. So here is the figure for this question. So how to solve it? So here I will explain to you step by step on the solution to solve this question. Firstly, we need to change the non-SI unit value become SI unit value. It is given in the question the value of R in centimeter. We need to change it into meter, and then the value of current into ampere and theta into pi. After that, we need to determine that the angle that we need to use for this question. As you guys can see here, before this, in the question only provide us the angle of theta. But however, it is actually phi that we want to find because the phi angle is representing the angle between the sector of the configuration. So we can find it by subtracting 2 pi minus with theta. And then we got the answer as 11/9 pi. After that, we need to find the suitable formula to be used in this question. Because in this question, we want to find the magnetic field at the center of circular arc. So we need to substitute the arc length formula, which is dl equals to r d theta. So here we can see that we got this equation. After that, we need to pull out the constants, which is current and radius, from the integral and put it at the left side of the equation. After that, the angle varies on the wire from 0 to theta. Thus, resulting the equation becomes like this. So the magnetic field is equals to nu naught I theta divided by 4 pi r. So after we have the formula, we need to substitute all the value into the formula. And then we obtain the magnetic field values at the central circular arc as 0.272 microtesla. Tesla is the unit. And then we need to determine the direction of the magnetic field. So to determine the direction of the magnetic field, we need to use this formula. Firstly, if the current is in counterclockwise direction, just like this, the direction of the magnetic field is out of the page. Vice versa, if the current is flow in clockwise direction, just like this, so the direction of the magnetic field will be into the page. So in this case, the equation gives us that the direction of the current is counterclockwise. So the magnetic field of this central circular due to the current is out of the page. So that's all from me. Thank you.
In conclusion, we have learned the background history, definition, equation, application, and problem solving of Biot-Savart's law. Biot-Savart's law is very important as its application is very practical in our daily life, such as cell towers, magnetic reaction, and wireless power transfer. I think that's all from us. Hope you enjoyed the video. Thank you.